The topic is about the variants and the types of CAN protocols. To understand about the variants, here the overview of the variants and the classical CAN, CAN-FD, CAN-XL, CAN-Open, DeviceNet, J1939, SAE 11898, and LIN. So these are the variants that involved in the device to communicate with multiple ECUs or the single ECUs to transfer the data. Coming to the overview, here the CAN Controller Area Network Protocol has evolved over the years, leading to several variants that cater to different applications and performs the requirements and capabilities. Coming to the classical CAN, here it have a standard CAN and it have the identifier length of 11 bit and it follows the message ID where it can be configured up to 2048 unique message IDs and we can transfer the data of 8 bytes of data and it will be suitable for simple automotive application with fewer nodes. And coming to the extended CAN, it have an identifier of 29 bits and message ID allows up to the 5 billion unique queue message IDs and data payload allows up to 8 bytes of data and application used in complex system with many issues such as the modern vehicles and industrial automation. Coming to the CAN-FD is the flexi data rate. It introduced in 2012. So the CAN-FD enhanced the classical CAN by allowing the flexible data rate and the larger payloads. Coming to the identifier length of the CAN-FD, it supports up both 11-bit and 29-bit identifier, and payload will be 64 bytes of data can be transferred on one frame, and the bitrate it will be operated up to 8 Mbps for transmitting of the data among the devices. And the application used in ADAS system and infotainment and other industrial application where larger data transfers and faster communications is established over the CAN-FD. And coming to the CAN-XL, CAN-XL is the upcoming variant designed to further increase the capability of the CAN. Its identifier length is supports up to 64-bit by identifier, and data payload will be it can be transferred up to 2048 bytes of data at a time, and the bitrate it can be operate up to 10 Mbps. And the application intended to further automotive application include the ADAS and the higher bandwidth communication is required for transmitting of the data over the CAN-XL. And coming to the CAN-Open, so it is a higher layer protocol based on the CAN, primarily used in industrial automation. And the future, it supports the device profiles and network management and object dictionaries. And applications here, it used for the communication between the devices in the embedded control system and mostly used for the manufacturing areas and the robotics sections. And coming to the DeviceNet is the another high layer protocol based on the CAN developed for industrial automation. And the future focus here connecting the industrial devices like the sensors, actuators, and other controllers. And applications it will be commonly used in factory automation and process control. Next, we have the J1939. Here, it's the higher layer protocol based on the CAN, primarily used in the heavy-duty vehicles and commercial trucks. Here, its future defines the set of standards for communication between the ECUs in heavy vehicles, including the diagnostics and control and monitoring. And the application used in trucking and the constructions and the agriculture machineries. And SAE 11898, here it is referred to the ISO standard that includes define the CAN specification under the ISO layer, where it follows the electrical and physical layer characteristics. And the variation here, it will be the specification it will be differ on the physical layers. The CAN high and CAN low speed and CAN flexible to support the various applications and environment. And next we'll have the LIN. It is the local interconnected network. It's a low cost and low speed alternative to the CAN, often used in automotive applications for non-critical communication. And it featured designed for simple sensors and actuator network, and commonly used for body control models and wind controls and lightning system in the vehicle. So coming to the variants and the types, what we discussed on the summary part, the classic CAN, it will be support 11-bit, 29-bit, and the data byte will be the 8 data bytes will be transferred, and typically the application basic automotive in system. And CAN open, it varies the identifier, and data payload, it also varied, and industrial type, industrial automation. CAN XL, we can transfer up to 2048 bytes of data, and the identifier it will support up to 64-bit, and it is a future automotive system. And CAN FD, it have the 11 and 29-bit identifier, and the data payload up to 64 bytes of data can be transferred at a time. And DeviceNet, it is varies here with respect to the identifier and data payload, and mostly used for the industrial factory automation. And J1939, it varies the identifier and data payload data, so it used for the heavy duty vehicles. And SAE 11898, it also identifier and data payload varies specific to the CAN specification we are using. And LIN,